All right, so Web 3.0, where we are at with public blockchains. I am Sam MacPherson. So, we've had a long road to here. Satoshi Nakamoto descended from the heavens and created Bitcoin, and we're all very grateful for that. He also created the technology behind it, which is the blockchain, which is the interesting part. So fast forward to 2015, there was a lot of sort of development on the way, a lot of interesting things happened, and then Ethereum hit, which had the genius idea of basically combining all the nice aspects of blockchain with a generalized computation model. Now, we go to 2017, I'm sure many of you know the intense craze that happened, the ICO bubble. Much like the dot-com boom, I think a lot of people are aware something sort of big and pivotal is coming, but people don't quite understand it, so they're just throwing money everywhere. So now we're here in 2019, just before sort of where the tech is hitting another pivotal stage, Ethereum 2.0. So right now, where we're at is there is a lot of potential that can be unlocked, but there is non-trivial problems that need to be solved. These are technical barriers. And we definitely need to solve these before we can unlock the vast majority of the applications that can come out of this stuff. So we're very much in the infrastructure stage right now. So, big technical problems. There is scaling. Currently, we are limited to about 15 transactions per second. We use proof of work model, which is starting to be a little out of date. The economic cost to secure the network is quite high for proof of work. You're burning CPU cycles to reinforce the network that could be used for other and more important things. And ASICs, application-specific integrated circuits, are emerging more and more, which is becoming problematic for centralization. Another issue is currency volatility. Fluctuations 10% or more in a single day are not uncommon, and that's an issue if you want to use something as a payment system. More problems that there are is privacy. Computation is done out in the open. That's bad if you want to run a business or something. It makes no sense to run it out in the public. Oracle's another problem. Basically, blockchains are kind of this isolated thing, and we need some way of getting data from the rest of the world into them. And I'll get to more like the details on this stuff as we go. I'm just doing a high-level overview right now. So storage is another problem. Storing things on the blockchain is expensive. Like, you do not want to store a file on the blockchain. It makes no sense to. So we need sort of another piece, which is the storage layer of this whole thing. We also have identity. Right now, the whole thing is pretty pseudo-anonymous, and we can't really map cryptocurrency addresses to individual people. So scaling. Vitalik Buterin famously said, blockchain systems can only have at most 2 of the 3 following properties. And this is pretty fundamental to blockchain. You can basically pick 2 out of those 3 and make your choice, and you have to kind of stick with it. So all the things so far, yeah, they've had to pick 2 of these 3 things, and there hasn't really been a general solution to get all 3. So yeah. So sharding is a new thing that's coming out. Ethereum 2.0 introduces the concept of sharding. And much like database sharding, I'm sure most of you are familiar with that, it's a very similar idea. Basically, we have a limit of 15 transactions per second. Let's split the network into 1,000 shards. Therefore, you get 1,000 times speed up. And as long as you sort of keep things reasonable, you set a constant, sort of like you pick 1,000 and you stick with that, and there's enough people reinforcing the network, you can get things to stay decentralized and secure enough while getting that speed up. Another interesting model is the concept of DAGs, directed acyclic graphs. It's basically, this is a fancy way, it's sort of like a generalization of the blockchain as we know it, where there's one block at a time, and they just come one after the other. We allow each block to have multiple parents, and this allows sort of a nice you get parallelization within a single shard or blockchain. Because of the nature of blockchains, the computation being done is highly disjoint, so you can get pretty parallelizable speedups with this. A recent development, actually, as I was preparing this talk, Kasper Labs is a company that actually just emerged in the past week, who is currently building an Ethereum-like sort of structure, but are implementing with a DAG structure. So it will be interesting to see how they go with that. Consensus. So, proof of work. Currently, it's the most commonly used consensus model to secure blockchains. Works pretty well. It's been working for Bitcoin for 10 years, and there hasn't been a major hack. Basically, the idea behind it is you exchange electrical energy in the form of computation to secure the networks. The downside of proof of work is that it's vulnerable to 51% attacks, which is basically when 51% or more of the network conspires to make a bad transaction, then you can get the protocol breaks down at that point. And this becomes more likely as a smaller number of actors can control the mining. And this actually happened pretty recently in Ethereum Classic, the hard fork from Ethereum. There was a 51% attack where people are allowed to basically double spend their money. So ASICs, the application-specific integrated circuits, are a big problem with this because they make it cost prohibitive for smaller organizations and individuals to compete against the big dogs who can basically put all this money up front and build these very powerful computer circuits. So enter proof of stake, and this is not to be confused with delegated proof of stake. It's a different system. So Kasper Proof of Stake is the leading candidate to be implemented live first. There is no blockchain that currently has it right now. So the idea behind it is instead of putting up electrical energy as the cost to secure the network, let's stake the cryptocurrency itself, right? Because then you're not wasting CPU cycles, and there is value in the currency in itself, so why not use it? So these solve all the problems of proof of work, and generally it's thought of it as sort of the next phase to get into. So proof of stake continued. So there are some problems with it. So what if some cartel ends up controlling most of the ether supply? So the answer to this and many other problems is you can basically, because we're in our own world, we can control all the code, we construct games to prevent centralization. So a good example of this I don't know if this is part of the Kasper protocol specifically, but in Ethereum 2.0, they have these slashing rules where if you behave badly, either intentionally or not, say your staked node gets hacked, that's also your fault. If a large part of the network is hacked at once, then it is the fault of those who are not securing it properly, and they get penalized more harshly than they would if just a small portion got hacked. Basically, this and a couple other rules make it so that cartels end up being large honeypots, and then it becomes cost ineffective to form these sort of large centralized structures. All right, stablecoins. Why do we need stablecoin? The average user does not want a currency that fluctuates in value on a day-to-day basis. You can't really transact in it. So fixed supply coins such as Bitcoin act as more of a commodity like gold, silver, etc. Maybe you can get an argument about whether gold is a good way to transact for money on a day-to-day basis, but my belief is that it's not. And I think the market agrees with me because 2018, there was a massive rise in the sort of variety of stablecoins that were available. A lot of these from big names like the Winklevoss brothers and various other large names in the industry. So the interesting thing is decentralized stablecoins. So most stablecoins are backed one-to-one by an issuing authority, a central party, i.e. you give them $1, they give you $1 as an IOU. So at any point you can redeem your IOU and get your $1 back. So MakerDAO is kind of unique in this regard in that there is no centralized authority issuing the tokens. Instead, anyone is allowed to back a DAI token by at least $1.5 in Ether. And the issuing authority is a smart contract instead of a central authority. DAI is rapidly beginning to dominate the decentralized finance space as the stablecoin of choice for dApps. You can see this. This is a website, DeFi Pulse, that sort of measures how. And DeFi is decentralized finance, by the way, if anybody doesn't know. So this, there's $300 million locked up as of a recent date, and MakerDAO is dominating it by about 90%. So privacy. So token fungibility. To be fungible means that each token is worth the same as every other one. So having a public blockchain means that you can follow the trail of every piece of cryptocurrency as it moves hands. Sometimes it's useful, sometimes it's not. In particular, this is bad for fungibility because of the ability to flag certain coins as different from others. Perhaps these tokens are stolen or whatever. There's less bad reasons to not want, or to want fungibility rather. So Monero was actually one of the first tokens to provide fungibility for one-time transfers. It's running into some privacy attack vectors for recurring payments, but it's pretty good for now. Zcash is an interesting new one that is using zero-knowledge proofs to provide privacy. So, zero-knowledge proofs. This is an interesting new research topic that's emerged fairly recently, yeah. So, we can solve the problem of privacy with zero-knowledge proofs. And so, from Wikipedia, in cryptography, a zero-knowledge proof or zero-knowledge protocol is a method by which one party, the prover, can prove to another party, the verifier, that they know the value of X, without conveying any information apart from the fact that they know the value of X. So this is pretty abstract, but you can think of this as I'm performing a bank transaction, and I can prove that what I've done is correct in terms of the consensus around the blockchain, but anybody who verifies it can verify whatever I'm doing is correct, but they don't know what I'm doing. So I can, they don't know if I'm making a bank transaction or what the hell's going on, or even I did it, or who I'm sending it to, or they know nothing other than whatever just happened there was correct. So some initial solutions are popping up on the Ethereum 1.0 blockchain. Zero-knowledge DAI is an interesting first example. These are very experimental things, so they're pretty new. General privacy on Ethereum is in the works, and it'll be available somewhat soon. So oracles is another problem. The oracle problem. Blockchains have no access to external data, but we do need external data to do pretty much anything useful, right? So the solution is to have an oracle to submit data to the blockchain. But then we run into another problem. How do we trust these oracles? So one of the interesting solutions to this problem is called Witnet, a blockchain that's purely devoted to fetching data from web APIs used by randomized sources. They plan to launch in Q4 2019 with Ethereum support. Whether they'll be the de facto standard of this, who knows? But there's a lot of work being done on this, and it's something that's being tackled right now. Storage. So you've probably heard of maybe one or two of these. IPFS is pretty popular right now. Swarm and storage. So these are all nice sort of first attempts at getting decentralized storage right. There's definitely some issues that still remain. Object permanence is one of them. If I store a file and send it out to this ethereal cloud of decentralized storage, how do I guarantee that my file is not going to be, or that's going to be available, 5 days in the future if I'm not hosting it myself? So there's some interesting sort of incentive programs that are being worked on. Like Filecoin is a sort of corollary to IPFS, and Swarm has its sort of token incentivization model, same with storage. And another thing is sort of for the end user, most requests actually kind of go through gateways, web gateways, because we don't have a native decentralized storage loading system in the browser. So a lot of stuff just goes through like Cloudflare has an IPFS endpoint, so people just use that. Identity. Who is this address, right? So traditionally, to do identity, we use centralized authorities to verify one's identity. A common case of this is the government. They provide you a SIN number, they provide you a driver's license, etc. Without some sort of identity system, we can kind of only go so far with this tech. So how do we get the same level of identification without all relying on some single authority? So an interesting solution is Uport, and I think they're one of the leading sort of candidates for getting this right. Is they use this thing called P2P attestations to form sort of a web of trust. So your government can be some entity in this thing, and they probably have a lot of clout. They can sort of say, hey, this person is indeed who they say they are, and then your bank can be like, yep, I agree. And then even your family or your friends or whatever, it all sort of solidifies these, this web of trust, basically. The nice thing in this is there's no central gatekeeper. if your government becomes corrupt, if your bank goes bankrupt or whatever, you've still got the rest of the people reinforcing your identity. So this is still very much a research problem. I don't really know of any sort of big programs out there in the wild that are getting a lot of traction, but it's being worked on. So yeah, that's it. Thank you. Done. Oh, questions? Questions? Sorry, I can't hear you.
Maybe we have to line up.
Yeah, can you just come up here? Oh yeah, so to those of you who don't know, Quadriga CX, I think they were the largest Canadian cryptocurrency exchange. The founder may have stole a bunch of money or something. Who knows? He died in December supposedly in India, and basically the company is bankrupt, and they owe people who put money in about $190 million. Will they get their money back? I have no clue. So this is a good reason. Don't trust in centralized institutions like that, such as Quadriga, right? They can go bust. It's happened before. Mt. Gox famously went bust in 2013, and they were had most of the crypto at that time. So the best thing you can do is hold it in a hardware wallet and own your own funds, and then you are not at risk of this.
So what if you own your own wallet and then you die? Just your family has no access to it at all with it?
It's a good question. So what happens if you have your own wallet and then suddenly you die, right? So there's a couple sort of people that are working on this problem. So directly holding a wallet, I think that is something that is kind of, because we're in the first stages of this, it's going to become kind of antiquated, and we will sort of get these things encoded into the blockchain eventually, such that you can program in an inheritance or whatever, and then you get attestations by an insurance company or government or whatever. Yes, this person's died, therefore relinquish their funds to next of kin or whatever. So you're screwed now. I guess the short answer is you're screwed right now, but maybe in 5 to 10 years, it'll mirror what we have in society right now. What's up?
How will this tech power the next generation of web technologies?
Can you be more specific?
Well, you mentioned that it was going to power the Web 3.0.
Yeah.
What does that look like to you?
Oh, so this is very much the infrastructure phase. So I view it we had HTTP and stuff like that in the 90s. It was around for a little while, and then the web sort of started booming in 2000 and beyond, and we got sort of things like Facebook and Google and all that. So this right now to me is sort of the infrastructure phase for Web 3.0, and the bonus things we get that we didn't have in Web 2.0 is things like identity, sort of a base currency built into the system as a whole. There's a whole bunch of better things that come out of it, and I think most of us are aware of the issues with these large, dominating tech companies right now. Yeah. More questions? Thank you.